Here we go. I'm going to go through the performance and usability of font loading. I got a lot to cover. Thanks for inviting me, Steve. Thanks for Velocity for having me. So we're just going to dive right in after I turn my little clicker on. All right, so we're going to learn everything we can about font face today, which really what I'm trying to convince you of today is that the default behavior for font loading is harmful to both the perceived performance and integrity of content on the web. Oh, wait, oh, there we go. Font loading joke for you. So yeah, I'm Zachary on Twitter, Zachary.com. I work at Filament Group. We try to make the web work for everyone. Make the web work for everyone. All right, so font face. It's a pretty popular web feature. It's used at 47% of the top 1,000 websites, according to HTTP Archive, which is Steve's awesome website. And on average, it incurs about a 97 kilobyte payload per site. So in 2012, the average was 13 kilobyte. So it's almost a 650% increase in just 3 years. Well, when we look at the overall makeup of our pages and we look at the transfer size of our web fonts, really the impact of web fonts is not really that great, especially when we compare it to images or JavaScript. And you might have heard this said before, if you're worried about JavaScript, the amount of JavaScript that you have on your page, just remove an image, right? That's a misnomer, because byte for byte, different assets have different impact. And not all requests are created equal. So really we want to talk about the perceived performance of our pages. So when it comes to images loading on our pages, this is how they typically load, with PNGs and baseline JPEGs. They just kind of chunk in. So yeah, images take up a large portion of our page weight, but they really have a lightweight impact on our perceived performance. And this is how CSS works, blocks render. So when the CSS file finally loads, that's when our page renders. Here's the default behavior for JavaScript. Again, blocking, and we can improve this with defer and async attributes, but this is the default behavior. This is how web fonts work. I'll play it again. Hides the content while the web font's loading, and then when the web font successfully loads, it shows the content again. So web fonts have a non-trivial performance impact on our pages. So if you've been micro-benchmarking your JavaScript for loops, maybe it's time to take a look at how web fonts affect your page. So for today's agenda, we're going to go over two different things: how to trigger a font download on your page and the behavior of your page while a font is downloading. So we'll just start with very simple syntax. Here's a font face block. We have our font family there. You usually don't need quotes on there. You put a comma delimited list of different font formats that you want to use. And the browser will just pick the first one it supports and download. And I don't want to talk about formats too much, but I do have a couple slides on it. So in your source property, you want to use WAF2, WAF, and OpenType format. Stop using SVG. It causes bugs in older browsers, and it's really unnecessary now. But if you don't have an OpenType format font, you can also use TrueType format. Browser support is very similar. If you have an OpenType format, you'll get a couple extra features included, ligatures, small caps, some extra nice things that go for web typography. And you definitely want to use WAF2 because it's on average. Google did a study across all their Google web fonts. It's about 30% smaller than WAF. So it's great performance impact, reducing the amount of content that needs to be downloaded for our fonts. So when we take our font face block and just dump it on a page, so we put in some HTML. This is the bare minimum HTML. And then we look at the network inspector. It says 0 out of 1 requests were made for fonts. So no font requests were made. And 1 request, I guess, is not the correct English way to do plurals. So we'll just go ahead and reset the board. It's now been 0 days since our last pluralization errors. But the point I'm trying to make is that if the font is not used on your page, it's not downloaded. So to get the font to download, we have to actually add an element that uses our web font to our HTML. So if we add a simple paragraph tag in Firefox and IE9+, this will cause the web font to download. In your WebKit and your blinks, you actually need a non-empty element. So the element has to have content for the web font to download. And here's just a simple compatibility table for that. On the left, you'll see fonts are downloaded with a non-empty attached element in your document. And on the right, you'll see it downloads with an empty attached element. And on IE8, it downloads every time, which is fine. It's a little slower. If you want to restrict your font download to specific characters, you can use something called UNICODE range. So fonts are actually made up of different code points that point to the different characters or glyphs in your font. So for example, hex 41 maps to uppercase A in the Latin alphabet. 2bibity maps to the plus sign. 370 maps to the question mark. And code points allow us to use different fonts for the same content. So here's an example of UNICODE range. Say I wanted to use a completely different font just for ampersands on my content. This is kind of a contrived example, but we'd put UNICODE range 26, which represents the code point for ampersand. And we'd have a separate font file for that. So in WebKit and Blink, when we have an element on our page that uses our ampersand font family, this will not actually download the web font. No request captured. You need an ampersand in the content itself to make the web font download. And this is kind of interesting, right? Because font family does not need to be an element level property, right? We can restrict it to specific characters inside of an element. So here's a compatibility table for that. On the right, you get the smart download feature from Blink. And on the left, the fonts will always download when they're used in a font family, but the UNICODE range will still selectively apply your code points to only a subset of the content that you specified in UNICODE range. And of note, Firefox doesn't support this yet. It's behind a flag, but it's coming soon. So when it comes to using fonts on our page, we know that fonts are only downloaded when they're used in document content, but the font face matching algorithm also matches to other things. So for example, font weight, how bold the font is, and font style, which is our italics and obliques. There's a couple of other things also, but they're less popular. So we'll just go over those. So to specify a font weight and a font style, we just add those properties into our font face. And then inside of our elements, we'll just specify those as well. So we have a font face that has font weight 400 and a font style of normal. Then our element CSS has a font weight of 400 and a font style of normal as well. So it matches exactly. Congratulations, your font's going to download. But the matching algorithm does require an exact match for font family, but font weight and font style do not have to match exactly for the font to be downloaded. So inside of font face, there's kind of a division when it comes to font weights. There's lighter weights, which go from 500 and on down. There's heavier weights, the bolder weights, which go from 600 to 900. And this is important when it comes to determining what font is going to be downloaded. So say, for example, we have an element with font weight 500, font style normal. The matching algorithm will actually look for a font face with an exact match first. If it doesn't find one, since we're on the lower end of the font weights, it will actually go through 500, 400, 300, 200, 100. The first one it finds is the one it's going to use. If it doesn't find one in that range, it'll go loop back up, look for 600, 700, 800, 900. Again, it will use the first one it finds. And if it doesn't find any of those, it will actually loop through this whole entire thing again using font style italic. So for example, we have our paragraph here. Because we're on the lower end of the spectrum, it goes 5, 4, 3, 2, 1, and then 6, 7, 8, 9. And it will use what it finds. So in this example, we want font weight 100, which is the lightest font that the lightest weight that's available to us. But the only font face that we have on the page is font weight 600, which is a bold. It will use the bold to render. Same thing for italic. We have our paragraph style, which is normal here, but only italic is available. It will use the italic. And so here's an example of on the upper end of the font weight spectrum. So we have a font weight, our paragraph is font weight 600. It will actually count up first instead of counting down. So we'll go 600, 700, 800, 900, and then 5, 4, 3, 2, 1, and then again repeat the same thing with italics. But the more interesting part of starting out in the upper portion of the font weight spectrum is that if it crosses over into and doesn't find 600, 700, 800, 900 and crosses over into this lower portion, it will try and, the browser will generate a new web font, and they call it faux bold. So it uses something called font synthesis to try and generate a web font from what it has. So for example, we have our font weight 500, which is what is available to the page. We want 600. It will, so that you can see that I've kind of included on the left-hand portion here, this is the true font weight 600, and this is the font synthesized faux bold version. So they've taken, the browser has taken font weight 500 version and added a little bit extra weight to it programmatically to generate a new sort of weird in-betweener faux bold version. And you can see that it's actually bolder than the native font weight 600 that you can get in the browser. And the same thing will happen for italics. It will try and generate an italic web font. If it crosses, if you want italic, if your paragraph is expecting italic and you only have normal available, it will try and generate an italic for you. And so this behavior is actually controlled with a property called font synthesis, which is very important for font loading polyfills, which I'll talk a little bit about later. But unfortunately, font synthesis is almost not supported anywhere. Firefox is the only one that has it right now. And this compatibility table is actually provided by Bram Stein. He has this great website called State of Web Type. So if you're interested in typographic features and browser compatibility around that, definitely check out that tool. But this faux italic and faux bold font synthesis problem really manifests itself when we only include a single font face on our page, and we try and use HTML, which has browser default styles, so strong, bold, emphasis, and italics elements on our pages. So I'm going to really put myself out there and say that we want to be frugal with how many font face blocks we include on our page, but not too frugal. So a good typeface, in my opinion, is some of the best kilobytes that we can spend on our performance budgets. So just for a real-world example, if you go to Instagram.com, you can look at their source, and they actually use 6 different variants of Proxima Nova on their page, so 6 different font face blocks. And this is how it renders. Almost all their content is using web fonts. The rest is images. And if you look at their network inspector, only 3 out of 26, only 3 of those 6 font faces are actually downloaded. You remember they had 6 font face blocks on their page, but only 3 were downloaded. And okay, if you look at the actual content that they're using here, you can see a bold. You can see bold there. You can see Roman here, the non-bold. But there's no third web font here. It's loading italic, but it's not actually using italic. So if you dig in a little bit deeper, I don't know if anybody works for Instagram here, but I'll do you a little free tech support here. The home icon here is actually, it's not a font icon. It's a background image on an element they have on this button. Can anybody guess what element this is? It's an I element. So that has a default font style of italic, which triggers the italic web font to be downloaded. So the only thing they need to do to save for about 13 kilobyte on their homepage load is just to add this and reset because they're not actually using the italic font. It's just downloading for no reason. So if they added that, they'll save about 13 kilobyte on their homepage. So the problem manifested with the I element, but it just could have just as easily manifested with any of these elements that have default browser styles associated with them. So we went through using document content, font weight, font style. So we know how to trigger a font download and how the font face matcher decides when to download a font. Now let's talk a little bit about how the browser behaves when the font is downloading. So a lot of people think that when the font face is parsed is an important moment in the font download lifecycle. That is not actually true. There's only two really important things that you need to think about when you're talking about web font performance. That is one, when the font starts downloading, and we learned the considerations or the things that trigger a download, and then when a font finishes downloading. So when the font is downloaded, it's parsed, the content is repainted and reflowed. So while the font is downloading, in most browsers, you're going to see nothing. So invisible text. Nothing is shown, no fallback text is shown to the user while it's downloading, and then when the web font successfully loads, it will swap in and re-render the font or the text using the new web font. So this is known as the flash of invisible text, or FOIT. And you can see this if you actually go to facebook.com. So this is a web page at test.org film strip running under ideal network conditions, so cable. So on facebook.com, you'll see that there's a lot of text sort of missing here. And so for 200 milliseconds, while the web font is loading, there's no text really shown to the user there. There's an article in the New York Times from, I believe, a Google developer had stated that people visit a website less often and slower than a close competitor by more than 250 milliseconds. So it's important to note that this 200 milliseconds delay that Facebook had on their facebook.com website is an additional delay just for the web font. So we looked at ideal network conditions for facebook.com, but what if the network conditions are not ideal? So let's look at Instagram again, but this time on 3G. Remember how it loaded 3 fonts? So the first one was Roman. It took about 1.3 seconds to load. And then 300 milliseconds later, it popped in the bold version. This was a great tweet that said, if a page hasn't loaded within 3 seconds, up to 40% of users will abandon the site. So does Instagram really want to spend 53% of their crucial 3 seconds just to avoid rendering fallbacks text? I would say probably not. Here's another example from apple.com. This is iPhone 5S on 3G. 5 seconds after initial render, the hero image loads. And then another 3 seconds after that, the web font loads. And this is important because the very last frame in the film strip is when the actual text renders. So maybe not the best thing for trying to get progressive rendering on your website. So the one thing that browsers have started to do to try and combat this problem is they included a timeout. So Blink and Firefox have both included a 3-second timeout. And if the web font doesn't load in 3 seconds, it will pop in or swap in the fallback font. And then when the web font finishes successfully after that, it will re-render using the web font. So this is known as the flash of unstyled text, or FOUT. But the question I would ask is 3 seconds a good timeout for that? Remember, if a page hasn't loaded in 3 seconds, you're going to get users to abandon your site. So really, we're kind of betting the farm on our font requests. I don't think that's a good thing. But web fonts are not just a performance problem. The invisible text actually affects the integrity of your content as well. So James Musprat tweeted out this great picture. It was I think a month or two ago when Mitt Romney they were wondering whether or not he was going to announce his candidacy for president. And this is the screenshot he took of Slate.com, which is the Apres web font for its titles. And you might notice that there's some interesting white space here, which actually the web font hadn't finished loading. So they used a separate italic web font on this headline. And so it completely changed the meaning of the title because the web font had introduced a separate flash of invisible text. Remember, each individual web font you use on your page has a separate flash of invisible text. So we'll just go ahead and forever refer to this problem as the Mitt Romney web font problem. And of course, it's no coincidence, if you remember one of my earlier slides, that 47% of websites use web fonts no matter what. There are 40% of websites that are dependent upon design, who believe they're performance victims, who believe that web fonts have a responsibility to care for them. Web fonts are not an entitlement, okay? So obviously the Romney web font problem is not good. Interestingly, Internet Explorer does something completely different. They don't have any invisible text at all. They'll show the fallback font right from the beginning, which I prefer. So let's just review this real quick. Flash of invisible text shows nothing while the web font's loading. It pops it in. We have a flash of invisible text to a flash of unstyled text at 3 seconds, which is gecko and blink. It shows nothing up to 3 seconds if the web font hasn't loaded before that time. And then it swaps in the web font after. And Internet Explorer has just shows the fallback the entire time. So there are those in the web performance community that will ignore the performance angle, and they'll ignore the content integrity angle, and they'll just say, well, the flash of unstyled text is ugly. But I would say the same thing has been said about progressive JPEGs as well. The fuzzy first pass is ugly, right? Some of the same things said. Now progressive JPEG is a first-class citizen on webpagetest.org, so progressive rendering is a good thing. So I prefer the flash of unstyled text. You may not. I would argue that going with the 3-second timeout is not a good solution. So in the interest of super awesome punditry, I'm going to give you a continuum of solutions that I think are okay. So on the left, we can do nothing and just embrace browser default. We can standardize on the infinite timeout, so Safari and mobile Safari behavior. And on the right, we can have a timeout where we swap to unstyled text, or we can have a 0-second show the fallback the whole time. So if you embrace browser defaults, I would say that this is actually very bad for your users, because it makes font requests a single point of failure. Because if the font request doesn't complete, your content will never render. And you think, oh, well, the user can just press the stop button. No, stop button does nothing. The user's only recourse is to reload the entire page, which frustratingly often actually shows the fallback text while you're leaving. So before we go on to the right way to do it, I want to talk a little bit about a few anti-patterns that I've seen kind of crop up. And I remember how I said that too many people will rely on when the font face block is actually parsed to interpret web font loading performance. So there's an over-reliance on CSS onload. So here's an example from a very popular web blog that I asked them to correct, and they haven't corrected yet, so I'm using it in my presentation. They use a blocking font request, and then on load, they'll add a class here to the document body, and then trigger that class to show the web font. So in their font CSS, they might have 2 font face blocks like this. It's really not as important. This is how it works, right? So the blocking font CSS will load there, and the blocking font request will load after. So the fonts start loading after the font CSS has been parsed and downloaded, but onload is triggered here. So we have quite a bit of time before the fonts finish downloading. So we're kind of beholden to browser default behavior in between onload and when the fonts finish loading. But in fairness to the blog, they also talk a little bit about async CSS, which is another mechanism that you can use to sort of toggle a media attribute in onload to load the font CSS in an asynchronous manner. But really, the only thing that this does is switch the initial request from being a blocking request to an asynchronous request. The problem is still the same. The fonts start downloading here, onload is triggered here, and until the fonts finish downloading, we're still going to have browser default behavior. If you want to learn more about loading CSS asynchronously. It's kind of a completely separate topic. Filament Group has a great tool for this. It's Load CSS. Steve mentioned it a little bit. Backwards. Animations, what is that about? All right. And actually at Filament Group, we tried to use this for web font loading as well. So we stuffed our actual font formats into data URIs and loaded the big, giant style sheet asynchronously using Load CSS. Which actually worked pretty well, right? Because the font data URIs start loading here, and the font data URIs finish loading here, and we repaint here, but actually there's still a very short amount of invisible text that we incur from this approach, and we've kind of moved on from it. And you can kind of see that there, 200 milliseconds. We think that that was probably due to, because it was more exaggerated on low-powered devices, so we think that probably was due to data URI processing overhead. Another anti-pattern is Alibaba.com. They have one big, giant 50 kilobyte CSS request and no font requests, and they've actually just dumped data URIs for their font faces right into their main blocking style sheet, which is not good because the fonts actually weigh 26 kilobyte after gzip, so they've almost doubled the size of their blocking main CSS just to avoid this flash of invisible text. So they blocked render of everything to avoid invisible text on just a portion of their page, which is not good. So the argument I'm trying to make today is that we want to embrace more unstyled text. So let's go to the right-hand side of our continuum here. And one of the tools that we could use, or one of the tools that's coming soon to solve this problem, is the font rendering CSS property. It's still sort of being worked on currently, but it's kind of the holy grail, though, right? Because then we can specify in CSS how we want our fonts to load, but it isn't yet implemented anywhere. So we have to use something else, the CSS font loading API, which is actually a JavaScript API. And there are polyfills for that. There's one called Font Face Onload, which I wrote, and there's another called Font Face Observer, which is Bramstein's. They're both really good. I mean, his is probably better than mine, but whatever. So the easiest example we can go through here is how to implement unstyled text from the beginning, sort of the standardizing on the Internet Explorer behavior. This is what it looks like with the CSS font loading API. We just call the load method on the API, pass in our font family, and then when it's loaded, we just use a very similar mechanism to what some of the other things we're doing before. Just add a class to our document. And then we'll use that class to sort of apply the new font family. And this is how the waterfall kind of looks for it. So the font request goes out, font starts loading. Since we're programmatically triggering the font request, we can kind of control that. And we don't repaint until the font finishes loading. So we're not beholden to any browser default behavior, since we only apply the font family until after the font is downloaded. And this is kind of how it renders. We have a fallback text. When the font loads successfully, it triggers, it swaps in the new web font. And if you use a polyfill for this, you can get this standard behavior in all web browsers. A little bit more difficult to implement is flash of invisible text with the in-second timeout. I'll just go quickly through this since I don't know how much time I have left. About 5 minutes. So we apply a loading class to the document when the JavaScript loads. After a second, we have a set timeout on a fallback. And then we use the exact same mechanism we were using before. When the font is loaded successfully, we apply a new class there. And here's what the CSS looks like for this. We hide our text, which is not the best practice, but for this contrived example, this is how we're going to do it. Hide our text using color transparent. After the fallback loads, or after the web font is successfully loaded, we change it back to color inherit. And then we use the exact same mechanism to apply our web font. And this is how that will render. So from 0 to 1 second, nothing will be shown, invisible text. At 1 second, we'll time out and show the fallback font. And then when the web font comes back successfully, it'll swap it in. But this won't actually, if we have any amount of invisible text, it won't actually solve our Mitt-Romney web font problem. Because if you're combining italic and bold with if you're combining more than one web font together, you're still going to suffer this problem. So one thing you can do to work around this is combine your repaints. So just use a promise, pass in both here. So we have our 400 weight Railway web font that comes in. We have our bold Railway web font that comes in. And then when all of these load, that's when we apply the Railway loaded class to repaint our page. So starts loading, and we only repaint after both finish loading. Another approach for this is two repaints, so a staged repaint. So we sort of divide our web fonts into our Roman and sort of everything else, our other variants, so our bold italic, and maybe if you use a combination bold italic font. So we put our Roman up front so we can trigger that most jarring reflow and repaint as soon as possible. And then we'll sort of load the remaining web font variants in a separate stage and repaint again. So in between, when the Roman loads and when we repaint at the end of our second stage, we actually will trigger that font synthesis, faux bold and faux italic versions that we talked about before. And so here's kind of what that might render like. So here's a paragraph of some text that I got from a recruiter, so recruiter Ipsum. It uses Arial and Arial Bold. And then when EXO loads, the Google Web Font, it will re-trigger. So this is just the Roman has loaded successfully, and I've highlighted the faux bold versions. It's kind of really hard to see that they're bold, and that's just a byproduct of the weights I'm using. But then when the second stage completes, it will re-render just those bold versions, or the italic versions, or whatever you might be loading in your second stage. And this approach is, I'm not going to go over the implementation details of that because it's a little bit more complex. But if you want to check that out, you can check out my blog post. It's called The Flash of Faux Text. But really, we want to minimize the fallback to the web font reflow because that initial Arial to EXO jump that I had shown is really kind of jarring. And there's a couple of things that we can do to work around that. We can sort of mess with different default font families. And if I have a tool called Font Family IO, which is actually just a giant compatibility table for default fonts on different operating systems and web browsers. But we can also use font size adjust, which adjusts the X height of your fallback font. Browser compatibility is not quite great for that yet, but it's still worth using because it's a progressive feature that we can use today. And also line height. And if you want a little bit more detail on how that works, you can check out Jason Pimentel's blog, Web Font Tune-Up Time. He has a blog with some examples using the WebKit, or the TypeKit web font loader. So there are a lot of tools kind of at our disposal to ease the transition from fallback fonts to web fonts. But again, the default browser behavior for font rendering is harmful to both the perceived performance and integrity of content on the web. So please use a font loading strategy and don't accept the defaults. Thank you. Do we have time for questions, or does anybody have any questions?
How well do the polyfills actually work?
So the polyfills work pretty well. I mean, it depends on how you structure your page. So if you're trying to avoid putting a polyfill in the first 14 kilobyte, because there's in the first 14 kilobyte of your page's content to kind of help your initial page render, it's going to be less helpful to do that. I don't know. The one I built is about 1.5 kilobyte gzipped. So there is a cost there. I think it's worth it, but really it depends on your page. But once the CSS font loading API is implemented in more places, that will be easier because we can just use that natively. And then also the font rendering CSS property will be the best thing for all of that. So, does that answer your question? Any other questions? Steve?
For the faux font generation stuff, how computationally intensive is that? How long does it take? Does it affect other things like rendering and JavaScript execution if those are trying to vie for parallel resources?
That's a good question. I haven't done any research on that, so that would be worth looking into. But yeah, I don't know. Oh, sorry. So Steve asked if the font synthesis actually vied for computational resources and took away from other rendering rendering performance for other things on the page. I don't know. It's a good question. Yeah.
How do things change when you start entering a single page application territory? Or are there any resources out there?
Yeah, so single page is, it really depends on when, so when the fonts download and when they're finished, or when they start and when they finish downloading. So if you front load all of your font loading, or all of your font loadings using some of the techniques that we have here, you can eliminate unstyled text, but it's really going to be no different for a single page app. I mean, the initial render of a single page app, the same considerations are taken for initial render on single page apps as they are non-single page, multi-page apps. But yeah, so the performance problems are really the same. So a lot of people, I think, take single page apps to mean we don't need to worry about initial render as much, which is, again, I would say something I don't agree with. So yeah, I think it should be no different. Any other questions? Yeah.
Do you have any insight into the user perception of the unstyled text? Like going from unstyled to style, how the user impact?
Well, again, so I mentioned the default behavior on Safari, how it doesn't have a timeout at all. That's very problematic when the font face doesn't complete. The font face request doesn't complete. You won't see any text at all. So I would say unstyled is better than not having any text at all. But again, you can play around with those defaults to see what's best for your users. But you can also adjust the fallback CSS properties for your text to make those jumps less noticeable. And you can go on Twitter and see people complaining about web fonts loading very slowly. There's a lot of tweets out there about that. So, yeah. That's probably not the best answer to your question, but I haven't done any user studies directly, so.
How do you change your font rendering strategy for people who are visiting the site for the first time versus people who are visiting a second time or potentially have assets attached?
Yeah, so at Filament Group, we actually set a cookie when the user has visited the page. So we try and use that cookie to gauge whether or not they're a repeat view or not. And so we'll actually load our web fonts in a blocking manner when it's a repeat view. And that's because we assume that the font will be cached. So this is mostly for initial page render stuff. So are we out of time? Okay. Thanks all.